Dear students, under the topic beta and gamma functions, here we have a very significant property. That is, we are going to find the relationship between beta and gamma functions. Now, the relationship between the beta and gamma function is given by beta of m comma n is equal to gamma of m multiplied with gamma of n divided by gamma of m plus n, where m and n are parameters. Now, first step is we have to write the definition of gamma function. So we have already seen in our previous video lectures where we learned the definition of gamma function given by gamma of n is equal to integral 0 to infinity e power negative x to the power n minus 1 dx for all n greater than 0. So we have to take this and write now. So we have taken and written the definition of gamma function and we have marked it as equation 1. Now here we are going to make a substitution. That is, we will be substituting x to be equal to t square. We are doing so because we want to find the other form of gamma function in order to derive this relationship. So in order to find the other form of gamma function, we will be making a substitution. So the substitution is put x is equal to t square. So this is the substitution for x. So if we put x is equal to t square, so we will be replacing this x and the x over here as t square. What about this dx? So that we have to find. We have to differentiate this x with respect to t in order to find dx. So we will be having dx by dt is equal to, we know that the differentiation of t square is 2t. And so from this dx is equal to 2t dt. So we have obtained dx from this. And we should also remember, whenever we make a substitution, we should also change the limits. So how to change the limits? We have to check when x is equal to 0, what is the value of t? And when x is equal to infinity, what is the value of t? That is, so we have to check for the limits. So when x is equal to 0, what is t? So if you put 0 over here, t will be equal to 0. So t is equal to 0. So this is the first limit. The second limit is infinity. So when x is equal to infinity, what about the limits for t? If you see, if you put infinity over here, t will also be equal to infinity. So as x varies from 0 to infinity, the value of t also varies from 0 to infinity. So that is what we have. Now we will make all these substitution in this equation 1. And so this gamma of n will turn out to be gamma of n is equal to integral, the limits are for 0 to infinity, from 0 to infinity. So that we have to write, so 0 to infinity. At the place of x, we should rewrite it as t. So it will be t square the whole power m minus 1 multiplied with e power minus x. So e to the power negative, what is x? X is t square. So t square. And then dx. The value of dx is equal to 2t dt. So multiply this with 2t dt. So now we have transformed this equation, this function gamma of n. Now let us simplify this to get a proper form. So gamma of n will be equal to integral 0 to infinity. Now this can be written as, this 2 will be multiplied with m minus 1 and it will become 2m minus 2. So t to the power 2m minus 2. And then we have multiplied with e to the power negative t square. We have this 2. 2 is a constant which we can write out of the integral. So I am putting it outside the integral because it is independent of t. and so I have written, it's a constant, so I have written outside the integral. And this t, the power of t, if you see, it is 1, and here also we have a t, so we can add that 1 over here in the power, and then dt. So we have obtained this. After this, it will be equal to twice integral 0 to infinity t to the power 2m minus 2 plus 1 is minus 1, multiplied with e to the power minus t square dt. So this is gamma of m. And so therefore we have obtained gamma of m to be equal to twice integral 0 to infinity t to the power 2m minus 1 e to the power minus t square dt. And so we can mark this as equation 2. And this is gamma of n. Okay, so gamma of n. Now after this, we are going to make a change of the variables alone. So now in this gamma of n, okay, so in gamma of n, we are going to change the variable t as y. So wherever I am having t, I am going to just replace it by y in order to get gamma of n in terms of y. And so gamma of n will be equal to twice integral 0 to infinity, and t to the t is what? I am going to change it as y because it's a variable. So y to the power 2m minus 1 e to the power we have minus t square. So now in the place of t we have to change it as y. So we will be having minus y square and dt will become dy. So this is equation 3. Also, in order to obtain another parameter, for example, we want to get another parameter m. So gamma of m will be equal to, in this equation 2, we will change t as x in order to get another parameter. So it will become twice integral 0 to infinity x to the power 2m minus 1 and e to the power minus x square and dx. So this is equation 4. So now we have obtained gamma of n and gamma of m, and we have marked it as equation 3 and 4. Now further what we will do, we will multiply equation 3 and equation 4 and obtain gamma of m multiplied with gamma of n. So let us do that now. So multiplying equation 3 and 4, we get gamma of m multiplied with gamma of n. What is gamma of m? That is equation 4, this one. And gamma of n is equation 3. Now we will multiply these two in order to find gamma of m multiplied with gamma of n. So I will show you that now. So that is equal to, this is gamma of m. I have just rewritten these two terms, and this is gamma of n. So I am multiplying gamma of m and gamma of n. So now when we multiply these two integrals, it will be equal to, first we will multiply the constants. So 2 multiplied with 2 will become 4. And then it will become integral 0 to infinity, the first integral. And the second integral is again 0 to infinity. So I have taken and written both the integrals together here. And then I will write e power negative x square and e power negative y square together. So e power minus x square, e to the power minus y square, because we are just multiplying these two. And then x to the power 2m minus 1. Y multiplied with y to the power 2n minus 1, multiplied with dx dy. So this is what we obtain. We shall further rewrite this. So we will be getting gamma of m multiplied with gamma of n to be equal to 4 integral 0 to infinity, again integral 0 to infinity, and these two, the base are same, which is e. So the powers can be added. So it becomes e to the power, this negative sign I will take in common, and we will be having x square plus y square. And then multiplied with x to the power 2m minus 1, y to the power 2n minus 1, dx dy. And I mark this as equation 5. So all this is equation 5. Now again in this equation 5, we are going to make substitution method where we will be using the coordinates r comma theta. So what we are going to do is we are going to put x is equal to r cos theta and y is equal to r sin theta. So what will happen here? First we have to find x square plus y square. So x squared plus y squared will be equal to, what is the square of this? R square cos squared theta plus the square of this is r square sin squared theta. Now if you see, we can take that r square common. So it will be equal to r square multiplied with cos squared theta plus sin squared theta. But what is cos squared theta plus sin squared theta? It is 1. So r square multiplied with 1, because this is 1, r square multiplied with 1 is r square, and so this value is equal to r square. And therefore we obtain x square plus y squared to be equal to r square. So now in this equation 5, we have made a substitution, x as r cos theta and y as r sin theta. So we have obtained x squared plus y square, and directly we will be substituting these values over here. But what about this dx dy? So in order to find dx dy, so we know that already that dx dy will be equal to r multiplied with dr d theta. So many will have questions how we have got this dx dy to be equal to r dr d theta. This we have learnt in our one of the previous differential calculus paper under the topic Jacobian. So in order to find dx dy when x is r cos theta and y is r sin theta, the formula is the Jacobian of this, that is dou x dou y with respect to dou r and dou theta. So Jacobian of x and y with respect to r and theta I have written here, multiplied with dr d theta. So this is how we will be finding dx dy, where your x is r cos theta, y is r sin theta, using which we will find the required derivatives for the Jacobian, and then we will be substituting in the Jacobian and we get dx dy to be equal to r dr d theta. So I have just shown you how we are getting this. So you can but this is not a part of the proof, okay, because it belongs to the previous chapter, that is differential calculus. This we do not include in the proof, but you just remember the value of dx dy after the substitution of x and y as r cos theta and r sin theta is equal to this, that is r dr d theta. But for your understanding, I have just explained how it is. So you can just have a glance of this and observe how we have obtained dx dy to be equal to r dr d theta. Okay, so but this is not the part of the proof. So directly we can write dx dy to be equal to r multiplied with dr d theta. And now the left out is we have to find the limits, because whenever we make a substitution for the variables inside the integral, we should also have in our mind to change the limits according to that. So that we have to do now. We observe that the limits varies from 0 to infinity for both the integrals. So first this integral is for r and this integral is for theta. So we observe that for r also it varies from 0 to infinity, and for the other integral, that is x and y, for x it varies from 0 to infinity, y it varies from 0 to infinity, and using that we have to find the limits for r and theta. Now how to find the limits for r and theta? We know that we have to consider the first quadrant, because the limits here varies from 0 to infinity. So 0 comma 0 starts here for x and y, and the curve moves, it will tend to infinity. Okay, so as the values of x and y change. Now what about r over here? So if you see, r varies from 0 to infinity, because this angle is theta and this is the radius vector. So the radius vector varies from 0 and it keeps on moving. So it varies until infinity. So r varies from 0 to infinity. And what about theta? We observe that the r lies in the first quadrant. So we know that the first quadrant, the limit varies from 0. So this is 0 and this angle is 90 degrees. So 0 to pi by 2. So it varies from 0 to pi by 2. So theta varies from 0 to pi by 2, that is 0 to 90. The value of 90 in radians, we can write it as pi by 2. So that is what I have written here. So these are the limits. Now using all this, that is x squared plus y squared equal to r squared, dx dy equal to r dr d theta, and the limits, we will make a substitution for this integral and rewrite this integral. Let us do that now. So now let us take and substitute all this in equation 5. So in equation 5, first we have 4. So let us write that 4 over here. So 4 integral, the first integral is for r. Okay, so this integral is for r and this integral is for theta. So this will be integral r equal to, we saw that the limits for r is 0 to infinity and the limits for theta is 0 to pi by 2. So integral 0 to infinity, integral theta equal to 0 to pi by 2. And then what we have e to the power minus of x square plus y square. But what is x square plus y square? We have got it to be r square. So e to the power minus r square. And after that we have x to the power 2m minus 1. But what is x? X is r cos theta. So r cos theta to the power 2m minus 1. Next we have y to the power 2n minus 1. What is y? Y is r sin theta. So r sin theta to the power 2n minus 1. Then we have dx dy. But what is dx dy? R dr d theta. So we will be having multiplied with r dr d theta. So this is what we obtain. We shall further simplify this. So from this we get gamma of m multiplied with gamma of n to be equal to 4. So this constant 4 comes here. So 0 to, that is r equal to 0 to infinity, integral theta equal to 0 to pi by 2 e to the power minus r square. This remains the same. Now when we multiply this, here we have r to the power 2m minus 1. So r to the power 2m minus 1. I am gathering the terms of r multiplied with r to the power 2n minus 1. So we should add the powers. So plus 2n minus 1. And here we have r to the power 1. So plus 1. So I have added all the powers of the of r. Next here we have cos to the power multiplied with cos to the power 2m minus 1 theta. Sin to the power 2n minus 1 theta dr d theta. So this is what we obtain. And so that will be equal to, simplifying further, 4 integral r equal to 0 to infinity, integral theta equal to 0 to pi by 2 e to the power minus r square. Now in the power of r we have 2m minus 1 plus 2n minus 1 plus 1. So this minus 1 and plus 1 gets cancelled. And from these two we can take 2 common. And so we will be having r to the power 2 multiplied with m plus n. And we have one minus sign here. So minus 1. And then this remains the same. Cos to the power 2m minus 1 theta. Sin to the power 2n minus 1 theta dr d theta. So when we write, we should be very careful about the parameters. We should not change it or miswrite it. So be careful while writing it. Now we will, as the next step, we will separate r and theta. That is, we will put all the terms with respect to r under the integral r equal to 0 to infinity. And the terms with respect to theta, we will put under the integral theta equal to 0 to pi by 2. So let us do that now. So that will be equal to 4. I will put a bracket. So 4 multiplied with, what is the first integral we have? Integral 0 to r equal to 0 to infinity. So let me write that. So integral r equal to 0 to infinity. So where are the terms that we have r? We have to gather it now. We have e to the power minus r square multiplied with r to the power 2 multiplied with m plus n minus 1 and then dr. So this is 1. Then we have to take the limits with respect to theta. That is the integral with respect to theta. So theta equal to 0 to pi by 2. Now wherever we have the terms theta, we should put it into this integral. So we have here cos to the power 2m minus 1 theta. Then sine to the power 2n minus 1 theta. And then d theta. So this is another integral. So we have separated r and theta. Now in this will be equal to 4 multiplied with, now here we will separate the power of r. So it will be integral r equal to 0 to infinity e to the power minus r square r to the power 2 multiplied with m plus n multiplied with this r power minus 1. I will write separately, r power minus 1 dr. So this is one integral. The other integral, what happens is, we have already seen under property 6, that is integral 0 to pi by 2 cos power 2m minus 1 theta sine power 2n minus 1 theta d theta. We have already seen this property and we have learned that it is equal to beta of m comma n. So under this we have learned that beta of m comma n is equal to twice integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. So we are going to use this expression which is known as the second form of beta function. So from this integral will be equal to 1 by 2 of beta of m comma n. So because beta m and n are parameters, here if it is changed also, it's not an issue. So we will be using 1 by 2 beta of m comma n instead of this integral. So this full integral will be changed as 1 by 2 of beta of m comma n. Now we can see that this 2 and this 4 gets cancelled. So it is twice. So that's equal to twice. And then within the bracket we have integral 0 to infinity e to the power minus r square r to the power. Now this will be 2 multiplied with m plus n. R to the power minus 1 can be taken to the denominator and written as 1 by r. So 1 by r. And then here it should be dr actually. I have written d theta by mistake. So it is dr because we have dr here. So dr. So multiplied with dr and then multiplied with this 2 has got cancelled and we are left out with beta of m comma n. So on the left we are having gamma of m multiplied with gamma of n. So this is the expression that we obtain now. And this expression can be also written as gamma of m multiplied with gamma of n is equal to twice integral 0 to infinity e power minus r square, and for convenience I am writing r square whole to the power m plus n divided by r dr multiplied with beta of m comma n. And let us mark this as equation 6. So we will mark this as equation 6. Now again in equation 6 we are going to make a substitution. That is, we are going to put r square to be equal to t. And we will find what is dr and then we will take and substitute all that over here. So let us do that now. So we are going to make a substitution that t is equal to r square. So from this what will be dt by dr? It will be equal to 2r. And so we obtain dt to be equal to 2r dr. Now from this we can say that if t is equal to r square, we can say that r is equal to square root of t. Now let us substitute that over here. So dt will be equal to twice square root of t dt. And so from this we obtain dr to be equal to dt divided by 2 square root of t. So we need the substitution for dr. So we have got it. And we also know that r is equal to square root of t. Now we have to check for the limits also. So what about the limits? So when r is equal to 0, t will be equal to 0 again. When r is equal to infinity, t will be equal to infinity. So this is the limits. So limits remains the same. Now we will substitute all this, that is the limits, the value of r, the value of dr in our equation 6 that we obtained at the last. That is this equation. In this equation 6, we will substitute t in place of r. That is, we will substitute r square to be equal to t. So let us do that now. So we will be getting gamma of m multiplied with gamma of n to be equal to, now if you see, you have twice integral 0 to infinity. The limits are remaining the same. So twice integral 0 to infinity. After that we have e to the power minus r square. But what is r square? We have made the substitution as t. So e to the power minus t multiplied with, you have r square to the power m plus n. R square is t. So t to the power m plus n divided by, you have r over here. But what is r? R is equal to square root of t. So we will write that here. So square root of t multiplied with, we have dr. Actually this because I want to show that beta is out of the integral. Okay, so I multiplied with dr. But what is dr over here? We have obtained it here. So multiplied with dt divided by twice square root of t. And then this whole thing has to be multiplied with beta of m comma n. And so that will be equal to, we observe that this 2 and this 2 gets cancelled. And so we will be having integral 0 to infinity e to the power minus t to the power m plus n dt divided by the square root of t gets multiplied with square root of t, and root t multiplied with root t becomes t. So t and dt, and this whole multiplied with beta of m comma n. Now this t to the power 1, if it is taken to the numerator, it becomes integral 0 to infinity e to the power minus t to the power m plus n minus 1 dt. And this has to be multiplied with beta of m comma n. And by the definition of gamma function, we know that here the parameter is m plus n. So if the parameter is m alone, we will be getting gamma of m. If here the parameter is m plus n, and so this full thing will be equal to gamma of m plus n multiplied with beta of m comma n. This is by the definition of gamma function. We observe that this integral is a gamma function with respect to the parameter m plus n. So it will be gamma of m plus n multiplied with beta of m comma n. And on the left we are having gamma of m multiplied with gamma of n. And from this we get beta of m plus n to be equal to, this goes to the denominator on the other side, and therefore beta of m comma n is equal to gamma of m multiplied with gamma of n, the whole divided by gamma of m plus n. So therefore we have proved the relationship between beta and gamma function. This relationship is a very significant relationship because we will be using this relationship while solving many of the problems under definite integrals. So because of that, this is a very significant relationship. Therefore, beta of m comma n is equal to gamma of m multiplied with gamma of n divided by gamma of m plus n. So hope you have understood the derivation of this relationship. Thank you.